What's up, you freaking geniuses? So in this video, I'm going to teach you how to determine if an equation represents a function, right? Or another way we could say that is we're going to determine if an equation represents y as a function of x. But in any case, enough of that word salad garbage. This is pretty straightforward, okay? So in order to figure out if an equation is a function, all you have to do is solve for y, right? We just need to isolate this variable by itself. And once we do that, if we just have a single equation, that means that this original equation is a function, okay? But if once we isolate this bad boy, if we have several equations as our answers, okay, 2 or more solutions, then that means this equation is not a function, all right? So let's start with this first example. So here we have x squared plus y is equal to 1. So again, we just want to isolate y. We want to solve for y. So the first thing we can do is get rid of this x squared, so we can subtract x squared from both sides. They die on this side, and all we're left with is y is equal to 1 minus x squared. All right, so as you can see, we solved for y. It's by itself, right? How many equations, how many solutions do we have? Well, it looks like we just have this one single equation, right? So just one solution. So that means this original equation is a function. All right, here's the next example that we're going to try. So this time we have negative x plus y squared is equal to 1. Okay, so again, we just want to solve for y. So the first thing we can do is get rid of this negative x by adding x to both sides, right? They did cancel out over here. So we're left with y squared is equal to 1 plus x. All right. The next thing we can do is get rid of this exponent, the 2, and the way we can do that is by taking the square root of both sides. All right, so then on this side, the square root or the radical and the squared exponent cancel out. So then all we're left with is y is equal to plus or minus the square root of, looks like 1 plus x. Okay, so remember whenever you're solving an equation, whenever we get rid of that squared exponent, right here in front of the radical, we need to put this little plus minus sign, okay? So here, as you can see, we essentially got 2 solutions for y, right? So it's isolated. So now you can see that we have 2 solutions, right? We have y is equal to positive the square root of 1 plus x, and y is equal to negative, right? The square root of 1 plus x. So we got 2 different solutions. So that means this original equation is not a function, son. All right, here's the next example that we have. So here we have y is equal to the square root of 16 minus x squared, all right? So again, the first thing you want to do is isolate y, right? But as you can see in this example, y is already by itself. There's nothing that we have to do to it, okay? So there's absolutely nothing that we have to do to this problem. All we have to do is check how many solutions we have. And as you can see, we just have this single solution, right? Y is equal to the square root of 16 minus x squared. Okay, so since we just have this single solution, that means this bad boy right here is a function, all right? And just to be clear, you might be asking, why didn't we put the plus minus sign over here? Well, it's because we didn't do anything to y. If this equation first started as y squared, and we'd have to get rid of this 2, this exponent, where we have to take the square root of that bad boy, then yes, we would end up putting a plus minus over here, okay? But this problem didn't have that, right? It was just y by itself, so that's why we don't have to do anything here. Okay, here's the next example we have. So we have y is equal to 4 minus the absolute value of x. All right, so the first thing we want to do is isolate y by itself. And as you can see, just like the last problem, it's already by itself, okay? So that means we don't have to do anything to this side of the equation, all right? We just leave it alone. So since we just leave it alone, we can see we just have a single equation. So we just basically have a single solution. So that means this guy right here is a function, okay? Now, one other way that we can kind of deal with these absolute value bars and check to see if this is a function or not is by using something called the vertical line test, all right? So for instance, we can, let's do a different color, why don't we? So if I just graphed this really quick, here's the XY axes. And then let's just make a little table over here off to the side and plug in some points, okay? So let's plug in -1, 0, and 1, all right? So I'm going to plug in a negative number, 0, and a positive number just so we can see both sides of the graph, okay? So if we plug in a -1 right there, here we're going to get 4 minus the absolute value of -1, which is just 4 minus 1. And 4 minus 1 is equal to positive 3, right? So we're going to get a positive 3 if we plug in a -1 for x right here, okay? What if we plug in a 0? Let's clean that up. Okay, what if we plug in a 0 right here? Well, the absolute value of 0 is just 0, right? So 4 minus 0 is just equal to 4, right? So if we plug in a 0 for x, we're going to get 4 right here. Now, if we plug in a positive 1 right here, the absolute value of just 1 is just 1. So here we once again get 1. So again, 4 minus 1 is just equal to 3. Okay, so we got 3 points right here that we can plot. So we're going to say this is -1, 3. We'll say that's about there. 0, 4, we'll say is about there. And then 1, 3, we'll say 1, 3 is about there. Okay, so as you can see, and this is basically what all absolute value graphs are going to look like to a degree. They're basically just going to look like these V shapes. In any case, as you can see, that's the graph, approximately, of this equation, okay? Now we can do something called the vertical line test, which just says if you can draw a single vertical line through this graph and it only hits the graph at a single point, then that means the graph is a function, okay? So for instance, if I draw a vertical line right here, you can see that it only touches the function or the graph at a single point, right? This point right here, okay? What if we draw a vertical line right here? That's vertical-ish. You can see, again, it touches the graph at only a single point, this point right here, okay? And I think you get the picture, right? If we drew one over here also, right? It still only touches it at one single point. So since it only touches the graph at a single point, that once again means that this is a function. Now, if we drew that vertical line again and it somehow hit the graph at 2 separate points or 2 or more separate points, then that would mean that this is not a function, which we're going to do an example of. Hint, hint. But in any case, again, this one is a function. Alrighty, now we basically just moved the absolute value bars here, so you can see it's the absolute value of y is equal to 4 minus x. Okay, so in this case, again, we want to isolate y by itself, so we need to get rid of these absolute value bars somehow, right? And the way that you do that is you basically leave the side with the absolute value bars alone. What you have to do is split this equation up into 2 separate equations, all right? So what we're going to have instead is that y is equal to plus or minus whatever's on this side. So in this case, it would be 4 minus x, okay? That's basically how you can drop these absolute value bars. Again, it's just by putting a plus minus in front of this whole other side, okay? But as you can see, we basically split it up into 2 different equations again, right? So we have y is equal to the positive of 4 minus x, and we also got that y is equal to the negative of 4 minus x. Okay, so since we, again, get 2 different solutions, that means this equation is not a function, all right? And one last thing that I want to show you with this one is just the vertical line test one more time, because it's actually going to be kind of helpful. So with this guy right here, we can once again just plot a few points. So here, let's plug in a 0 and a 1. So if we plug in a 0 right here, we're going to get 4 minus 0. So we basically get the absolute value of y is equal to 4 minus 0, which is just 4, right? So here you can see that y could be a positive 4 or a negative 4, right? So we could have a positive 4 or a negative 4 for y. Okay, and if we plug in a 1 for x right here, 4 minus 1 is equal to 3. So now we get that the absolute value of y is equal to 3. All right, so then here we can see that this must be a positive 3 or a negative 3, right? The absolute value of either one of these, or both of these, is equal to 3. All right, so if we plug in a 1 for x, we once again get 2 solutions, right? Positive 3 and -3. So let's just plot these few points really quick. So we get 0, +4, we'll just say there, 0, -4 is about there, and then we also get 1, +3, and 1, -3. Okay, so again, your graph with an absolute value is going to look like a V. So this one kind of looks like maybe the point is right there, right where it turns. So the graph of this one looks something like that. Okay, but now this time, if I draw a vertical line through the graph, like so, you can see that it hits it at 2 different points. So that means that this graph and this original equation, again, are not a function. So if you found the video helpful, make sure to leave a thumbs up down below. And if you have any questions, let me know in the comments section below.